In this question, we have to find 12th term of GP whose 8th term is given by 192, and it is also given that the common ratio is equal to 2. Now, the only unknown in this question is your first term. So, we can use the formula of nth term to get A. So, 8th term can be rewritten as A r raised to 8 minus 1 is equal to 192. But we know that the value of r is 2. So, to get the value of A, we just have to make A subjective. So, we'll get A is equal to 192 upon 2 raised to 7. And we already have the common ratio. So, we are ready to get T12 using formula of nth term. We will get A r raised to 12 minus 1, where your A is 192 upon 2 raised to 7 and the common ratio is 2 raised to 11. So, here we'll get 192 into 2 raised to 11 minus 7, or we can say 4. So, we will get 3072 as your 12th term. Ta-da! In this question, we have one GP and we have to find nth term and 20th term. Now, from GP, we have to collect its fundamental terms, which is first term, which is 5 by 2 in this case, and common ratio of second term to the first term. So, here we'll get common ratio is equal to 1 by 2. Now, to get nth term, we have to use general formula of nth term, which is AR raised to n minus 1, where your A is given as 5 by 2 and R is 1 by 2. So, we'll get whole raised to n minus 1, or we can say your nth term will be 5 upon 2 raised to n. Similarly, to get 20th term, we just have to place n is equal to 20. So, we will get T20 is equal to 5 upon 2 raised to 20. Ta-da! In this example, we have 5th, 8th and 11th term of GP are given as P, Q and S respectively, and we have to prove that Q square is equal to PS. So, let's form equation. Your 5th term is given as P. Using formula of nth term, we can say it is AR raised to 5 minus 1 is equal to P, or we can say AR raised to 4 is equal to P. Similarly, your 8th term is equal to Q. So, we can say AR raised to 8 minus 1, or we can say AR raised to 7 is equal to Q. And finally, your 11th term is equal to S. So, we will get AR raised to 10 is equal to S. Now, let's try to get your left hand side, Q square, but your Q is AR raised to 7. So, we just have to take whole square. So, we'll get A square and R raised to 14. Now, similarly, let's try to get right hand side, which is P into S. So, your P is AR raised to 4 and S is AR raised to 10. So, we'll get A into R raised to 4 plus 10, or we can say 14. So, as you can see, your left hand side is equal to right hand side. So, we can say your Q square is equal to the product of P and S. Hence proved. Here, you should note that 5, 8 and 11 are in AP. 5th, 8th and 11th term of GP is also in another GP. Okay. So, remember this result for MCQs. Ta-da! In this question, it is given that 4th, 10th and 16th term of GP are XYZ respectively, and we have to prove that XYZ are in another GP. So let's obtain formulas. Your fourth term is equal to X. So we can say AR raised to 4 minus 1, or we can say 3 is equal to X. And it is also given that the 10th term is equal to Y. So we will get AR raised to 10 minus 1, or we can say 9 is equal to Y. Similarly, your 16th term is equal to Z. So we will get AR raised to 15 is equal to Z. Now, to prove XYZ in GP, we have to prove that your Y must be equal to X into Z whole raised to 1 by 2, or we can say your Y square must be equal to XZ. So let's try to obtain your left hand side, which is Y square, but your Y is equal to AR raised to 9. So we just have to square it. So we'll get A square and R raised to 18. Similarly, if we try to obtain your right hand side, which is product of X and Z, then get your X, which is AR raised to 3, and Z, which is AR raised to 15, will give us A square into R raised to 3 plus 15, or we can say 18. So as you can see, your left hand side is equal to right hand side, or we can say your Y square is equal to your XZ. Therefore, we can say XYZ are in GP. Hence proved. Ta-da! In this question, it is given that the fourth term of GP is equal to the square of second term, and the first term is given as minus 3, and we have to determine seventh term. So the only unknown of the question is R. So let's use the formula of nth term, which is AR raised to n minus 1. So on left hand side we'll get 4 minus 1, or we can say 3, and on right hand side second term will be AR raised to 2 minus 1, or we can say 1, the whole square, which can be simplified as A square and R square. So 1 power of A will cancel out and 2 power of R will cancel out, will give us R is equal to A. R is equal to minus 3. So we get our unknown, and we are ready to get seventh term, which is simply AR raised to 7 minus 1, or we can say 6, where your A is minus 3 and R is also minus 3. So we will get minus 3 raised to 6 plus 1, or we can say 7. So here we'll get minus 3 raised to 7, which is 2187. So we get our seventh term. Ta-da! In this question, we have to find which term of the following is 128. Now, our sequence is in GP, where its first term is 2 and common ratio of second term to the first term is root 2, or we can say 2 raised to 1 by 2. Now, let's try to find out number of term, which is 128, and for that we are going to use general form of nth term, where your A is 2 and R is 2 raised to 1 by 2, and 128 is actually 2 raised to 7. Now here we can reduce 1 power of 2, so we'll get 2 raised to n minus 1 by 2 is equal to 2 raised to 6. By comparing the power of 2, we will get n minus 1 by 2 is equal to 6, which will give us n is equal to 13. Ta-da! In this question, we have to find which term is 729. That means we have to find n. Now, our sequence is in GP, where its first term is root 3, or we can say 3 raised to 1 by 2, and the common ratio between second term and first term is root 3, or we can say 3 raised to 1 by 2. Now let's try to find out your number of term using general formula of nth term, where your a is 3 raised to 1 by 2 and r is also 3 raised to 1 by 2 is equal to 729 is actually 3 raised to 6. So on left hand side we will get 3 raised to n by 2 is equal to 3 raised to 6. Just compare the power of 3, you will get n by 2 is equal to 6, or we can say your n is 12. So we can say 12th term is 729. Ta-da! In this question, you have to find which term is 1 upon 19683. Now the given sequence is in GP, where its first term is 1 by 3 and the common ratio between second term and first term is given by 1 by 3. Now let's try to find n using formula of nth term, which is ar raised to n minus 1 is equal to 1 upon 19683, where your a is 1 by 3 and r is also 1 by 3, and 19683 is actually 1 upon 3 raised to 9. So on left hand side we'll get 1 upon 3 raised to n is equal to 1 upon 3 raised to 9, and if we compare the power of 3 we will get n is equal to 9. So ninth term will be 1 upon 19683. Ta-da! In this question, you have to find the value of x, for which your given sequence should be in GP. So the necessary condition for the terms a, b and c is b square is equal to ac. Here your b is x, a is minus 2 by 7 and c is minus 7 by 2. So here we'll get x square is equal to 1, or we can say your x must be plus or minus 1. Ta-da! In this question, you have to find sum of 20th term in geometric series of 0.15, 0.015, 0.0015 and so on. So in our GP, your first term is 0.15 and the common ratio between second term and first term is given by 0.1, which is less than 1. So for r less than 1, we have to use a into 1 minus r raised to n upon 1 minus r, where a is 0.15, then r is 0.1 and number of terms is 20. So in denominator we will get 1 minus 0.1, or we will get 0.90, and we know that 0.15 6 are 0.9, so we'll get 1 by 6. 1 minus 0.1 raised to 20 is your final answer. Ta-da! In this question, you have to find sum of n terms in GP, where the first term of the GP is root 7 and the common ratio between second term and first term is root 3, which is greater than 1. Now for r greater than 1, sum of n terms is given by ar raised to n minus 1 upon r minus 1, where your a is root 7, then r is root 3 raised to n minus 1 upon root 3 minus 1. Now for simplification, let's multiply and divide by conjugate of the denominator. which is root 3 plus 1. So we will get root 7 into 3 raised to n by 2 minus 1 into root 3 plus 1 whole divided by 3 minus 1, or we can say 2, can be considered as your final answer. Ta-da! In this question, we have to find sum of n terms of our given GP, where your first term is 1 and the common ratio between second term and first term is minus a, which we consider as less than 1. Now, for r less than 1, your Sn is given as a into 1 minus r raised to n upon 1 minus r, where your a is 1 and r is minus a. So in denominator, we'll get 1 plus a. So tada! This is your final answer. In this question, we have to find sum of n terms in GP, where your first term is x cube and common ratio of second term to the first term is given by x square, which we consider as less than 1. And for r less than 1, your summation is given by a into 1 minus r raised to n upon 1 minus r, where your a is x cube and r is x square. So in denominator, we'll get 1 minus x square, can be considered as your final answer. Ta-da! In this question, we have to evaluate summation of 2 plus 3 raised to k. Actually, we have two different sequences for k equal to 1 to 11 for 2, and the second series is for 3 raised to k. If we expand our first series, it will be 2 plus 2 plus 2 up to 11 times. And in second series, we will get 3 raised to 1 plus 3 raised to 2 plus 3 raised to 3 up to 3 raised to 11. Now, your first series is in GP having first term is equal to 2 and the common ratio of second term upon first term is given by 1 and the number of terms are 11. So, when your r is equal to 1, the summation is given by n into a, where n is 11 and a is 2. Or it's just a general knowledge that if we add 2 11 times, it will be 11 times 2, right? Okay, now let's move to the second series, which is also in GP, having first term is equal to 3 raised to 1, or we can say 3, and the common ratio of second term and first term is given by 3, which is greater than 1, and the number of terms are 11. So, for r greater than 1, the formula of summation is given by a2 into r raised to n minus 1 upon r minus 1, where your a is 3 and common ratio is 3 and the number of terms are 11. So, you'll get 3 raised to 11 minus 1 upon 3 minus 1, or we can say 2. So, finally, we will get 22 plus 3 by 2 into 3 raised to 11 minus 1 is your final answer. Ta-da! In this question, we have to find how many terms are needed of this GP to give summation is equal to 120. Now, to get the value of n, we need first term of the GP, which is 3, and the common ratio between second term and first term, which will be 3, and your common ratio is greater than 1. So, the summation of n terms is given by a into r raised to n minus 1 upon r minus 1, where your summation is given by 120, then the first term is 3, the common ratio is also 3, and we have to find the value of n. So, in denominator we'll get 3 minus 1, or we can say 2. Now, if we multiply 2 and divide 3, we will get 80 is equal to 3 raised to n minus 1, or we can say your 3 raised to n is 81, which is also 3 raised to 4. So, if we compare the power of 3, we will get n is equal to 4. Therefore, the sum of 4 terms of GP is 120. Ta-da! In this question, we have sum of first 3 terms of GP is 39 by 10 and their product is 1. Here, we have to assume 3 terms in GP and their product is given. So, it is preferable that your terms of GP must be A by R, A and AR. Now, it is given that their product is equal to 1. So, let's get their terms and multiply with each other. So, your RR will cancel out and you will get A cube is equal to 1, which will give us A is equal to 1. Now, to get R, we have to use another condition, that their sum is equal to 39 by 10. So, again, get the terms and take summation of them. And we also get the value of A, which is 1. Let's multiply whole equation with R and 10. So, you will get 10 plus 10R plus 10R square is equal to 39R. So, you will get a quadratic equation of 10R square, then 10R minus 39R, or we can say minus 29R plus 10 is equal to 0, and it can be factorized into 2R minus 5 and 5R minus 2 is equal to 0. So, here we'll get R is equal to 5 by 2 or R is equal to 2 by 5, and we already find out the value of A, which is 1. So, we are ready to find out your terms. For R is equal to 5 by 2, you will get 1 into 2 by 5, or we can say 2 by 5, then 1 and 1 into 5 by 2 will give us 5 by 2. And for R is equal to 2 by 5, your terms will be 1 into 5 by 2, or we can say 5 by 2. Your middle term still 1, and last term will be 1 into 2 by 5, or we can say 2 by 5. So, in both cases, required terms are 2 by 5, 1 and 5 by 2. Ta-da! In this question, it is given that sum of first 3 terms of GP is 16 and sum of next 3 terms is 128, and we have to determine the first term and the common ratio and sum of n terms. So, first of all, let's consider a GP having first term is equal to A and common ratio is R. Now, it is given that the sum of first 3 terms is equal to 16. So, let's get your first 3 terms and add them. So, it will be 16. Now, for simplification, we can take A common. So, it will be 1 plus R square is equal to 16. Let's say this is your equation number 1. Now, let's use next condition, which is sum of next 3 terms is 128. So, let's get next 3 terms and add them. So, you will get 128. Now, From equation, we can take AR cube common. So we will get 1 plus R square is equal to 128. So we will get your second equation. Now we have to solve them. So let's take the ratio of your second equation and the first equation. So your A and the bracket will be cancelled out, and we know that 16 8s are 128. So here we'll get R cube is equal to 8, which will give us R is equal to 2. So we get our common ratio. Now to get first term, let's use first equation and substitute the value of R. So you will get A into 1 plus 2 plus 4 is equal to 16, or we can say your A will be equal to 16 by 7. Now the last quantity which we have to find is sum of n terms, and for R greater than 1 your summation is A into R raised to n minus 1 upon R minus 1, where your A is 16 by 7 and R is 2. So we'll get 2 raised to n minus 1, and in denominator we'll get 2 minus 1, which is 1, which we can ignore. So we get sum of n terms as your last required term. Tada! In this question, it is given that 4 numbers forming a GP, in which here we have your first condition that your third term is greater than the first term by 9. So using general formula of nth term, we will get AR raised to 3 minus 1, or we can say 2 will give us A plus 9. For simplification, from these two terms, we can take A common. So you will get R square minus 1 is equal to 9. This is your equation number 1. And here we have the second condition, which says that the second term is greater than fourth term by 18. Again, we will do the same thing. AR, which is second term, is equal to AR cube plus 18, or we can say from these two terms we can take AR common. So we will get 1 minus R square is equal to 18. To get common factors, we can take minus common. So this will become R square minus 1. Now we have to solve them, and to get value of A and R, let's take a ratio of second equation to the your first equation. So here your A and R square minus 1 will cancel out, and 9 2s are 18. So we will get minus R is equal to 2, or we can say R is equal to minus 2 is your common ratio. Now to get the value of A, let's use equation number 1 and substitute the value of R, which is minus 2. So here we'll get A is equal to 9 upon R square minus 1, or we can say minus 2 square minus 1, which is 9 upon 4 minus 1, 9 by 3 will give us A is equal to 3. So we get the value of A and R, and we are ready to form our GP. Its 4 terms are A, AR, AR square and AR cube. So we'll get 3 into minus 2, or we can say minus 6, 3 into minus 2 square will give us 12, and 3 into minus 2 cube will be minus 24 are the required 4 terms. Tada! Here we have the question of GP, and it is given that the first term is 729, or we can say it is 3 raised to 6, and it is also given that the 7th term of the GP is 64. So to get the value of R, let's use the general formula of nth term, which is AR raised to 7 minus 1, which is nothing but 6, is equal to 64, which is nothing but 2 raised to 6. Now, if we substitute the value of A, which is 3 raised to 6, you will get R is equal to 2 by 3. Now, we are ready to get summation of 7 terms. Your R is less than 1, so your equation must be A into 1 minus R raised to 7 upon 1 minus R, where your A is 3 raised to 6 and R is 2 by 3 whole raised to 7, and in denominator we'll get 1 minus 2 by 3, or we can say it will be 1 by 3. For further simplification, we'll get 3 raised to 6 plus 1, and within the bracket, if we take LCM of 3 raised to 7, it will multiply with 1, and we'll get 3 raised to 7 minus 2 raised to 7 upon 3 raised to 7, which will be cancelled out, and you will get summation of 7 terms is equal to 3 raised to 7 minus 2 raised to 7, which is 2187 minus 128 will give us 2059 as your final answer. Ta-da! Here we have the question of GP. To get the first term and common ratio, we need two conditions, and we have two conditions. The first one is sum of first two terms is minus 4, and the second condition is fifth term is equal to 4 times of third term. So first of all, let's use your second condition, which says that your fifth term is 4 times your third term. So using formula of nth term, we will get AR raised to 5 minus 1, or we can say 4 is equal to 4 times AR raised to 2. So here your A and 2 power of R will reduce, and you will get R square is equal to 4, which will give us R is equal to 2 or minus 2. Now let's use your first condition, in which it is given that sum of first two terms is equal to minus 4, and we know that the first term is A and second term is AR of the GP. So let's take A common. You will get 1 plus R is equal to minus 4. So we will get A is equal to minus 4 upon 1 plus R. So we get two values of R equal to 2 and R equal to minus 2, and we obtain the equation to obtain your A. So in first case, R equal to 2, you will get A is equal to minus 4 upon 3, and the terms of GP are given as A, AR, AR square, and so on. So your first GP must be minus 4 by 3 into 2 will give us minus 8 by 3, then minus 16 by 3, and so on. And for R equal to minus 2, you will get A is equal to minus 4 upon minus 1, or we can say 4. So your GP must be 4, then 4 into minus 2 will give us minus 8, then 16, and so on. So we get our 2 GPs as the answer. Ta-da! In this question, we have 2 GP. Your first GP is 2, 4, 8, 16, and 32. And your second GP is given as 128, 32, 8, 2 and 1 by 2. And we have to form third GP, which is produced by product of corresponding terms of these two GPs. And it is obvious that the product of two GP is also GP, having first term is equal to 2 into 128, which is 2 raised to 7. So first term is nothing but 2 raised to 8, and the common ratio of second term, which is 4 into 32, to the first term, which is 2 into 128, will be 1 by 2, and the number of terms are 5, and we have to find summation of these 5 terms. Your r is less than 1, so summation will be a into 1 minus r raised to 5 upon 1 minus r, where your a is 2 raised to 8 and r is 1 by 2. So in denominator we will get 1 minus 1 by 2, which is 1 by 2. So this 2 will move in the numerator. You will get 2 raised to 8 plus 1, and 1 minus, we have to take the LCM of 2 raised to 5, so it will multiply with 1, will give us 2 raised to 5 minus 1 upon 2 raised to 5. So we will get 2 raised to 4, which is 16 into 31, will give us 496 as your final answer. Ta-da! In this question, we have to find product of the first sequence, which is actually in GP, and the second sequence, which is also in GP, should form GP. So let's find out our sequence by multiplying corresponding terms. So we get our sequence, and if it is in GP, then the ratio between consecutive terms must be equal. So first of all, let's try to find ratio between second term and first term. So it will be small r into capital R. Now let's try to find out ratio between third term and second term. So it is also small r into capital R. So we can say the product of corresponding terms of given sequence form a GP whose common ratio is small r into capital R. Ta-da! In this question, we have to find sum of n terms of sequence 8, 88, 888, 8888. So this is your special type of a series, and to solve it, we have to take 8 common. So you will get 1 plus 11 plus 111 and so on. Then we have to multiply and divide by 9. So you'll get 9 plus 99 plus 999 and so on. Now we have to split all the terms. Your 9 can be split as 10 minus 1, then 100 minus 1, then 1000 minus 1 and so on. So here we will get 2 series. In first series we have 10 plus 100, or we can say 10 square, then 10 cube and so on. And from second series we can take minus common. You will get 1 plus 1 plus 1 up to n times. So as you can see, your first series is in GP, having first term is equal to 10, and the common ratio between second term to the first term is equal to 10, which is greater than 1. So using formula of summation of n, we will get a into r raised to n minus 1 upon r minus 1, where your a is 10 and r is also 10. So in denominator, we'll get 10 minus 1, or we can say 9. Now, your second series is actually summation of 1 n times. So you will get n into 1. Ta-da! In this question, you have to find sum of following series up to n terms, which is 5 plus 55 plus 555. This is the special type of series. To solve it, first of all, you have to take 5 common. So you'll get 1 plus 11 plus 111 up to so on. Now, we have to multiply and divide by 9. So you'll get 9 plus 99 plus 999 up to so on. Now, we have to split all the terms. Your 9 can be split as 10 minus 1, then 100 minus 1, then 1000 minus 1, and so on. So here we will get two series. In first series, we have 10 plus 100, or we can say 10 square, then 10 cube, and so on. And from second series, we can take minus common. You will get 1 plus 1 plus 1 up to n times. So, as you can see, your first series is in GP, having first term is equal to 10, and the common ratio between second term to the first term is equal to 10, which is greater than 1. So using formula of summation of n, we will get a into r raised to n minus 1 upon r minus 1, where your a is 10 and r is also 10. So in denominator, we'll get 10 minus 1, or we can say 9. Now, your second series is actually summation of 1 n times. So you will get n into 1. So if you open the bracket, you will get 50 by 81 into 10 raised to n minus 1 minus 5n by 9 is your final answer. Ta-da! In this question, you have to find sum of following series up to n terms, which is 0.6, 0.66, 0.666, and so on. This is the special type of a series. So to solve it, first of all, we have to take 6 common. You will get 0.1 plus 0.11 plus 0.111 and so on. And then multiply and divide by 9. So you'll get 0.9, 0.99, then 0.999 and so on. Now, here we have to split the terms. 0.9 can be split as 1 minus 0.1. Then 0.99 will be 1 minus 0.01. Similarly, 1 minus 0.01 and so on. So here we'll get two series. The first one is summation of 1 n times, and from second series, if we take minus common, we'll get 0.1 plus 0.1 square plus 0.1 cube up to n times. So we can say the summation of first series, which is summation of 1 n times, will be n into 1, and second series is in GP, where your first term is given as 0.1 and the common ratio of second term, which is 0.1 square, to the first term, which is 0.1, will be 0.1, which is less than 1. So summation of n terms will be a into 1 minus r raised to n upon 1 minus r, where your a is 0.1 and r is also 0.1. So in denominator we'll get 0.9. So here we'll get 2 by 3 into n minus 0.1 by 0.9 will be 1 by 9 into 1 minus 0.1 raised to n. And to get the final answer, let's open the bracket. You will get 2n by 3 minus 2 by 27 into 1 minus 0.1 raised to n. Ta-da! In this question, we have pth, qth and rth term of GP are ABC respectively, and we have to prove this thing. So, let's assume our GP having capital A as a first term and capital R is its common ratio. So, we can say the pth term, which is equal to A, will become AR raised to P minus 1 is equal to A. Similarly, your qth term is B. So, we will get AR raised to Q minus 1 is equal to B. And your rth term is C. So, you'll get AR raised to R minus 1 is equal to C. Now, let's try to get your left hand side. For simplification, you have to substitute value of A, B and C. Now, let's collect the terms of A. In first bracket, we have A raised to Q minus R. In second bracket, we have A raised to R minus P. And in third bracket, A raised to P minus Q. Now, let's collect the terms of R. In first bracket, we have P minus 1 into Q minus R. Then, in second bracket, we have R raised to Q minus 1 into R minus P. And in third bracket, we have R raised to R minus 1 into P minus Q. In further simplification, we will get A raised to Q minus R plus R minus P plus P minus Q. And R raised to, if we multiply the bracket, we'll get PQ minus PR minus Q R. Then from second term, we'll get QR minus QP. Then minus R plus P. And from the last bracket, we will get RP minus RQ. Then minus P and plus Q. So, as you can see, power of A will be 0 as well as power of R will also become 0. And anything raised to 0 is 1, which is your required right hand side. So, we can say our left hand side is equal to your right hand side. Hence proved. Ta-da! In this question, it is given that your first term of GP is A and the nth term is given as B. So we can say AR raised to n minus 1 is B and P is actually product of n terms. So you have to prove this thing. So let's try to simplify our P. We have A n times. So we can say we will get A raised to n, and let's collect the power of R, which is 1 plus 2 plus 3 up to n minus 1. Now we know that 1 plus 2 plus 3 up to n is given as n into n plus 1 by 2. So if we replace your n by n minus 1, so we will get n minus 1 into n minus 1 plus 1 will become your n by 2. So we can say we will get a raised to n into r raised to summation of 1 to n minus 1 will be n into n minus 1 by 2. So we get our p. Now if we square both sides, we will get a raised to 2n and r raised to n into n minus 1. So here let's treat our a raised to 2n, which is a raised to n into a raised to n, and your r raised to n into n minus 1 will be remain as it is. So if we take whole raised to n common, we will get a into ar raised to n minus 1, which is actually your b. So we will get p square is equal to ab raised to n. Hence proof. Ta-da! In this question, we have to prove that the ratio of sum of n terms of GP to the sum of terms from n plus 1 to 2n is 1 upon r raised to n. So, to understand the question, let's consider one GP having first term as a and common ratio is r, having 2n terms. Now, we have to find ratio of sum of first n terms to the sum of terms from n plus 1 to 2n. So, if we use general formula, we will get a plus ar plus ar square up to ar raised to n minus 1, and in denominator we will get ar raised to n plus ar raised to n plus 1, ar raised to n plus 2 up to ar raised to 2n minus 1. Now in further simplification, your numerator will remain same, and from denominator we can take r raised to n common. So remaining terms are a plus ar plus ar square up to ar raised to n minus 1. So these terms will be cancelled out and we will get 1 upon r raised to n, which is your required answer. Ta-da! In this question, it is given that A, B, C, D are in GP. So we can consider your first term is A and common ratio is R. So we will get A, comma, AR, then AR square and AR cube. And we have to prove this thing. So let's begin from the left hand side and substitute the values. Your A is A, your B is AR whole square plus C is AR square the whole square. Similarly, in second bracket, we'll get AR the whole square plus AR square the whole square plus AR cube the whole square. So here we'll get A square plus A square R square plus A square R raised to 4, then A square R square plus A square R raised to 4 plus A cube R raised to 6. Now as you can see, from first bracket we can take A square common, so we'll get 1 plus R square plus R raised to 4, and from second bracket we can take A square R square common, so we'll get 1 plus R square plus R raised to 4. So your left hand side will be A raised to 4 R square into 1 plus R square plus R raised to 4 the whole square. Now let's move to the right hand side and substitute the values. Your A is A, B is AR plus B into C, which is AR square, then C into D, the whole square. So as you can see, we can take a square r common from the bracket. So we'll get 1 plus r square plus r cube. If we give individual square, so we'll get a raised to 4 r square and whole square. So we will get our left hand side is equal to right hand side. So we can say your a square plus b square plus c square into b square plus c square plus d square is equal to your ab plus bc plus cd the whole square. Hence proved. Tada! In this question, we have to insert two numbers between a equal to 3 and b equal to 81. So that the resultant sequence must be GP. That means we have to insert two GMs, and for that the first thing we need is b by a raised to 1 upon n plus 1, where your b is 81, then a is 3 and the value of n is 2. So here we get 27 raised to 1 by 3, or we can say your r is 3. Now let's find out geometrical mean, which is ar raised to n. For n is equal to 1, your first geometrical mean will be 3 into 3 raised to 1 will give us 9. Then for n equal to 2, you will get 3 into 3 square, or we can say 27. So we get our required numbers. Or we can say if we insert these two numbers, then 3, 9, 27 and 81 will become GP. Tada! Here we have one interesting question. We have to find value of n so that this number may be the geometrical mean between a and b. And we know that geometrical mean is under root of AB, but it is given that your geometrical mean is a raised to n plus 1 plus b raised to n plus 1 upon a raised to n plus b raised to n. So, if we move this term on the right hand side, we will get a raised to n plus 1 plus b raised to n plus 1 is equal to a raised to 1 by 2, b raised to 1 by 2 into a raised to n plus b raised to n. For further simplifying your right hand side, let's multiply whole term with a raised to n. So we'll get a raised to n plus 1 by 2, b raised to 1 by 2. And then multiply with b raised to n, we will get a raised to 1 by 2, b raised to n plus 1 by 2. And your left hand side will be as it is. Now, let's collect the terms of a raised to n. So, this a raised to n will be on left hand side and this term should be moved on the right side. So, it will become minus. Similarly, the terms of b raised to n should be collected on right hand side. So, this will become minus. Now, on left hand side, we can take a raised to n and half common. So, in first term, we will get a raised to 1 by 2 minus, from second term, we will get b raised to 1 by 2. Similarly, on right hand side, we can take b raised to n plus 1 by 2 common. So, remaining terms are a raised to 1 by 2 minus b raised to 1 by 2. So, these equal terms will be cancelled out and we will get a by b raised to n plus 1 by 2 is equal to 1. And we know that anything raised to 0 is equal to 1. That means your power must be equal to 0, which will give us n is equal to minus 1 by 2 as a final answer. Tada! Here we have one interesting question. It is given that The sum of two numbers is 6 times their geometrical mean. So let's assume that our required terms are a and b, and we have to show that their ratio is 3 plus 2 root 2 root upon 3 minus 2 root 2 root. So let's try to find out a by b. Here the sum will be a plus b and geometrical mean will be under root of ab. So to get a by b, we have to follow these steps. Let's say a plus b will be as it is, and in denominator we'll get 2 times under root of ab is equal to 3. Now we have to take component and dividendo. So in numerator we have to add numerator plus denominator, and in denominator we have to take numerator minus denominator. Similarly, on right hand side, we'll take numerator plus denominator and numerator minus denominator. So, on left hand side, we have x square plus y square plus 2 times xy, which is converted into x plus y the whole square. So, it will become root a plus root b the whole square. Similarly, in denominator we have root a minus root b the whole square is equal to 4 by 2, or we can say 2. Now let's take root on both sides. So we'll get root a plus root b upon root a minus root b is equal to root 2. So we get plus and minus. Now we just have to separate them. So let's use component or dividendo again. So in numerator we have to take numerator plus denominator, and in denominator we have to take numerator minus denominator. Similarly, on right hand side we'll get, so on left hand side your root b will cancel out, and root a plus root a will becomes 2 times root a, and in denominator your root a will be cancelled out, and root b plus root b will be 2 times root b is equal to root 2 plus 1 upon root 2 minus 1. So 2 will cancel out, and we get the ratio of root a by root b, but we need ratio of a by b. So let's take square on both sides. So we'll get whole square of root 2 plus 1 upon root 2 minus 1. Now let's simplify. Root 2 square, which is nothing but 2, plus 2 times root 2 into 1 plus 1 square, which is 1. Similarly, in denominator we'll get 2 minus 2 into root 2 plus 1. So your a by b is nothing but 2 plus 1, which is 3, plus 2 root 2 upon 3 minus 2 root 2 is your required answer. Hence proved. Tada! In this question, it is given that capital A and G are arithmetical mean and geometrical mean respectively between two positive numbers, and we have to prove that the numbers are a plus or minus under root of a plus g into a minus g. So let's assume that our two numbers are x and y respectively. So their arithmetical mean, which will be x plus y by 2, will be a, and geometric mean of xy is g. So here we can make y subjective, and it will be equal to 2 times a minus x, and square both the sides, we will get xy is equal to g square. Substitute the value of y in second equation, we will get x into 2 times a minus x is equal to g square, or we will get 2ax minus x square is equal to g square. So our quadratic equation is x square minus 2ax plus g square is equal to 0. To solve it, we have to compare with the standard equation of quadratic equation. So your a is equal to 1, b is equal to minus 2a and c is equal to g square. To get the solution, we have to find discriminant, which is b square minus 4ac, where your b is minus 2a, then a is 1 and c is g square. So we will get discriminant is equal to 4a square minus 4 times g square, or we can take root d is equal to 2 times under root of a square minus g square. So we are ready to get the value of x using minus b plus or minus root d upon 2 times a, where your b is minus 2a, so it will become plus 2a plus or minus your root d is 2 times under root of a square minus g square upon 2 times your a, which is 1. So we will get our required number is equal to a plus or minus under root of a square minus g square can be rewrite as a minus g and a plus g. Hence proved. Ta-da! In this question, it is given that arithmetical mean is 8 and geometrical mean is 5. Then we have to obtain quadratic equation. So let's assume that their roots are x and y. So arithmetical mean will be x plus y by 2 is equal to 8 and geometrical mean is under root of xy, which is 5. So from first equation we can make y subjective and it will become 16 minus x, and from second equation let's square both the sides. We will get x into y is equal to 25. So the value of y should be substituted in second equation. So you will get x into 16 minus x is equal to 25. Open the bracket and you will get 16x minus x square is equal to 25. And by rearranging the terms, you will get x square minus 16x plus 25 equal to 0, which is your required quadratic equation. Ta-da! Here we have one problem solved. The number of bacteria in certain culture is double every hour, and if there were 30 bacteria, or we can say initially we have 30 bacteria, then how many bacteria will present at the end of n is equal to 2 hour, n is equal to 4 hour, and after nth hour, and it is double in each hour. So let's say initially the number of bacteria is equal to 30, then at the end of first hour it will be its double, or we can say 60. Similarly, after 2 hour number of bacteria will be again double, or we can say 120. So we can say after 4 hour number of bacteria will be 30 into 2 raised to 4, or we can say 480. And after n hour it will be 30 into 2 raised to n. So ta-da! We get our required answers. In this problem sum, we have to calculate what will be rupees 500 amount to in 10 years after it deposited in bank, which pay annual interest rate of 10% compound annually. So here the deposit in the bank is equal to 500 rupees. Now the annual interest rate is 10%. So we can say after 1 year the amount will become originally deposited 500 plus 10% of 500, or we can take 500 common and we'll get 1 plus 10%, or it will be 0.1. So here we'll get 500 into 1.1. Similarly, after 2 years, it will become 500 into 1.1 raised to 2. So, after 10 years, your amount will become 500 into 1.1 raised to 10 rupees. Ta-da!